Unit 8 here is all about triangles and more specifically right triangles. And we've worked with right triangles a little bit before when we used the Pythagorean theorem. So we're going to start with that and then expand from the Pythagorean theorem to look at some other properties and theorems that involve right triangles. So let's remember that the Pythagorean theorem is a squared plus b squared equals c squared. So what we're going to do is we're going to use the Pythagorean theorem to find the hypotenuse of each of these triangles below. Now looking at letter A here, because these two sides are both 12, that means both of these angles here need to be congruent because this is an isosceles right triangle. And if both of these two angles that I marked in purple are congruent, that means they must be both 45 degrees. Because 45 plus the 90 right here equals 180. So that's going to come to play in a little bit here. So it doesn't matter which side you label A or B, but the hypotenuse is always C. That is always your longest side. So let's plug in these values. So 12 squared plus, I'll use a different color, plus 12 squared equals C squared. We don't know what that is. Well, 12 squared is 144. So 144 plus 144 equals C squared. We add 144 to both, or we add our like terms 144 plus 144 gives us 288 equals C squared. And then I'm going to take the square root of both sides. Now we want to simplify the radical. That's what our directions say. You can break this up into 144 times 2. And then you can try to take the square root of both of them. Well, you can take the square root of 144, that's 12, but you can't take the square root of 2, that's not a whole number. So that stays as the square root of 2. So the length of the hypotenuse here is 12 times the square root of 2. All right, now in letter B, again, this is a 90-degree angle. If this angle is 45, that means this one must be 45 as well, because 45 plus 90 equals 180. And again, this is an isosceles right triangle because both of these legs here are 7. And our hypotenuse is across from the box, the right angle. So we're going to have 7 squared plus 7 squared equals C squared. 49 plus 49 equals C squared. And then we get 98 equals C squared. And we'll take the square root of both sides. And again, we'll break this up into 49 times 2. And that will equal C. Well, the square root of 49 is 7. And we can't simplify the square root of 2. So that is our answer here. So let's look at both of these and see if we can come up with a pattern or a rule. So in letter A, both of the side lengths were 12, and our hypotenuse was 12 times the square root of 2. In B, both legs were 7, and the hypotenuse was 7 times the square root of 2. So I think you guys can see that if you have an isosceles right triangle, you know, that's the one thing that's similar about these is that besides the right angle, the other two angles are 45 degrees. So we have 45 degrees, and 90 degrees. So in an isosceles right triangle, we could just multiply the leg by the square root of 2. So now we know we don't have to use the Pythagorean theorem. We could just say, oh, if I know that this is an isosceles right triangle, so both legs are 40, or both angles besides the right angle are both 45 degrees, I can just take the leg and multiply it by the square root of 2. But what if you had to go opposite? What if I gave you the hypotenuse and I said, okay, now tell me how long the leg is? What's the length of each of the legs? Well, if you think about it, if I have the leg and I'm trying to find the hypotenuse, I multiply by the square root of 2. Now I'm going backwards. I have the hypotenuse and I want to go back and find the leg. Well, what is the opposite of multiplication? That is division. So we need to divide the hypotenuse by the square root of 2. So we're going to use that down here. Find the legs of the isosceles right triangles below. I have the 6 times the square root of 2. That is my hypotenuse because it is across in the right angle. If this is 45 degrees, this must be 45 degrees as well. So then I can take my hypotenuse and divide it by the square root of 2. These would cancel, and you're left with 6. So each of these legs are 6 units long. And you could verify that. You could use the Pythagorean Theorem and say, does 6 squared plus 6 squared equal 6 times the square root of 2 squared? You could always verify doing that. Now in letter B, again, we have our hypotenuse right here. It's across in the box. 45 degrees, this must be 45 degrees as well. So you would take that 12 and divide it by the square root of 2. Well, notice there's nothing to cancel out here. We don't have anything to make this a little bit simpler. So we needed to rationalize the denominator. And what that means is that I take the denominator, which is the square root of 2, and I multiply the top and bottom by that. Because remember, fractions you multiply straight across. So when I do this, I get 12 times the square root of 2, because I cannot combine those, over the square root of 2 times the square root of 2 is just 2. And then you say, well, 12 divided by 2, that can be done. That's 6. So then my final answer would be 6 times the square root of 2. So it does get a little bit more confusing when you have to rationalize the denominator, but just keep your rules straight and you're going to be fine. Don't freak out because your hypotenuse doesn't have the square root of 2 in it like we have right here. Just divide your hypotenuse by the square root of 2 and then simplify it. Now on the next page here, we're going to summarize what is called the 45-45-90 triangle theorem. So if the angles in a triangle are 45, 45, and 90 degrees, that means the hypotenuse is the square root of 2 times the length of each leg. Or the extended ratio is 1 to 1 to the square root of 2. So if we know one of the legs or one of the sides of a 45-45-90 triangle, it could be any one side, we could find the other ones. And like we discovered on the page above, the hypotenuse is equal to the leg times the square root of 2, and the leg is equal to the hypotenuse divided by the square root of 2. So number 1 here says a square has a side length of 5 inches long. What is the length of the diagonal? So let's draw a picture. And we know a square has all sides congruent. We also know that when I make a diagonal, what happens is that this angle is 45 degrees and this angle is 45 degrees. And we also know that all the angles of the square are 90. So now we have a 45, 45, 90 triangle right here. And the legs are both 5, which means the diagonal or the hypotenuse of my right triangle has to be 5 times the square root of 2. Now, number 2 here, it says, what is the perimeter of a square that has a diagonal length of 11 times the square root of 2? So again, let's draw the square. We don't know what each side is, but we know if we drew a diagonal, that this diagonal would be 11 times the square root of 2. Well, again, we know that this diagonal creates a 45, 45, 90 triangle. And then what we can do is say, well, the legs here that we don't know yet, that's going to be equal to 11 times the square root of 2 divided by the square root of 2. So then we would get 11. So each side of the square is 11 units long. So then that means the perimeter, remember perimeter is when you add up all the side lengths. So my perimeter is equal to 11 plus 11 plus 11 plus 11, or simplify that to 44. So remember to answer what the question is asking. It's not asking what one of the sides is, it's asking what is the perimeter of this shape. Number 3, I'm giving you the perimeter of this square and then asking what is the length of the diagonals. So if the perimeter is 112, well, there are 4 sides to a square and all the sides are congruent. So that means if I do 112 divided by 4 and get 28, that means each side here is 28. And now this is just like example number 1, where I just draw one of the diagonals. And when I do that, that creates a 45 degree angle, and a 90-degree angle. So we have this special right triangle here, and the legs of it are both 28. So that means the hypotenuse is 28 times the square root of 2. And that is my answer. Right, now, the last thing we're going to talk about today is how to determine if a triangle is acute, obtuse, or a right triangle based on the side lengths. And what we're going to use for that is the Pythagorean Theorem. So we're going to use the two shortest sides is our A and B term, and then the longest side is going to be C. So I'm going to set this up as 11 squared plus 14 squared equals 17 squared. So 11 squared is 121. 14 squared is 196. And 17 squared is 289. So when I combine like terms, I get 317 equals 289. Yes, obviously those are not equal, but what this tells us is that this is an acute triangle. So if this number is bigger, when you add up your A squared and B squared together, and that's what I did here on the left, I did 11 squared plus 14 squared, and I got 317, which is bigger than 289. So this side is bigger. So this is bigger. What this means is that we have an acute triangle. Acute triangle where all the angles are less than 90 degrees. Now we look at letter B, and we'll do the same thing. The two shortest sides are A and B, and the longest side is C. So I'm going to have 7 squared plus 18 squared equals 24 squared. So 7 squared is 49. 18 squared is 324. And 24 squared is 576. Combine our like terms. We get 373 equals 576. Well, again, of course, these two are not equal, but now this is bigger. This is bigger. The side that was just C, 24 squared, that was bigger than adding 18 squared and 7 squared. So this is going to be an obtuse triangle where where one angle is bigger than 90 degrees. And then here, A, B, C. So 9 squared plus 40 squared equals 41 squared. So we get 81 plus 1600, because 40 squared is 1600, equals, well, 41 squared is 1681. When we combine our like terms, we get 1681 equals 1681. So in this sense, these are the same. These are the same, which makes this a right triangle. Right triangle. Okay. So this is a quick way to see what kind of triangle you are dealing with in acute, obtuse, or right triangle. But the main idea today is this special 45, 45, 90 degree triangle. But as you saw at the very beginning, you don't need to necessarily know these rules. It just makes things a lot quicker. You can always use the Pythagorean theorem, but the shortcut here, this 45, 45, 90 special right triangle, makes life a lot easier. So I hope that you use this and practice it so that way you can apply it better later on. Thank you for watching the video. Make sure to smash that like button and subscribe.